Hello and welcome to exploring FHIR performance benchmarking. My name is Steve Johnston and I'm a solutions architect at AWS and UK healthcare team. I've been working with healthcare organizations in the UK for over a decade, but I was first introduced to FHIR when I joined AWS almost 2 years ago. My work with FHIR inspired my master's dissertation on the topic we'll explore today, which is FHIR performance benchmarking. So why might someone measure FHIR server performance? Well, when I looked into the academic research, I spotted two trends. The first was that there was those who were primarily interested in improving or assuring the performance of FHIR server implementations. And the second trend was around those who had a novel system or a feature built on a FHIR server and they needed to perform some sort of viability testing. To give an example of each of those that were interested in performance were doing things such as creating a microservices architecture and comparing that versus a monolith to show the improvements in performance as it horizontally scales out. And in the case of the novel systems or features, that might be something like a FHIR facade, which then has some sort of a health data store behind it, or an EMR, or perhaps a machine learning workflow. And they need to test it to make sure that the responsiveness is adequate to meet the likely user need. When it comes to industry, it's much more likely that they're going to be interested in doing performance benchmarking for assurance reasons to make sure that a specific deployment is going to meet the demand that will be put on it by the expected user base. And so how can we go about this then? How can we measure FHIR server performance? Well, this is really going to depend on what you're trying to gain from your results. So in my case, I was trying to perform a generic benchmark with a wide range of interactions and with commonly used resource types. But really, if you should try and tailor it to your specific production workload. So make sure that you're using interactions on the resources that you're likely to use in that production workload. And that way you can get as close to what the live system is going to be like as possible. To do all of this, you're going to need synthetic data, and maybe you have some, or maybe you can generate some. In my case, I use Cynthia to generate synthetic patient data. And then you're going to be doing some measuring of response time, which is going to be in seconds or milliseconds. And you'll also be measuring the throughput or the transactions per second. And you'll use these to compare the different deployments. Tools, libraries, and scripts can make all of this much easier. I've come across many, and I've just included some on the screen. So digging into my prototype's high-level requirements, it was to act as a FHIR client, and it's to check the capability statement before proceeding. It's to store the synthetic patient data and the job execution data. It's to perform a set of FHIR interactions, creates, reads, updates, and deletes against a certain FHIR server, and to measure the time taken for those interactions to complete. It's going to need to support single thread and multiple thread workloads. The reason behind this is because single thread would simulate a server which is under no load at all, in which case it's going to yield the best possible outcome, best possible results for that particular interaction. And then the multiple thread workloads would have many parallel interactions occurring at the same time, therefore simulating a busy server, a server that's under load. I would also support single resources and bundled resources. And I'd like to try and clean up where possible. So any resources created should be deleted. And I'd like to output in a format that's easy to work with, easy to use. Okay, so let's have a look at the components. So I created this in Python because that's what's familiar with me, and I knew I could prototype this quickly in it. I used a lot of the built-in libraries, and I used TinyDB, the NoSQL implementation, and requests for its TTP operations. I isolated some of the responsibilities, so the FHIR client interactions were in their own module, and the I/O operations, so operations to disk and to database, were also in their own module. There is a database for the patient data and another for the job data, and it would also output to JSON files. On the screen now, I show a sample of one of the jobs, and this is what an entry in the job data database would look like. Important points to call out from here, apart from the naming, would be at the bottom, we've got the references to the patient database where some of these bundles can be found in this case, or resources can be found. So init start and init end show where the initialization bundles are located, and row start and row end show where the patient data is located. Now, what's the initialization bundle? Well, that's something that's generated from Cynthia. So it generates these initialization bundles, which include details of practitioners and hospitals. And by loading those in your FHIR server, the patient data can then refer back to those. On screen now, I'm showing a sample of what the JSON output would look like. And this has the test name at the top, PAT SGL, and then the reference of the resource. So PAT1, and I used 1,000 patient resources, so there would be 1,000 of these entries. And then within each one, there would be each of the different interactions in turn. So create, read, update, delete. And for each of those, I ran the interaction 5 times. So you can see there's 0 through to 4. And 0 is expanded here to show the contents, which includes the status code, the R time or the response time, and various other aspects of data I was collecting. To look at the workflow then, essentially once you execute benchmark.py, you provide it with the base, the URL to the server, and the port that's in use. And it would check the capability statement, make sure that the interactions and the resources are supported before proceeding. It would then load the job and the patient data into memory. It would then load the initialization bundles into the FHIR server. I did have a switch to disable this because once you've done it once, you don't need to redo it unless it's a different set of patient bundles with a different set of initialization bundles. And then from there, it would run through each of the test jobs in turn. So we've got the single threaded patient, create, read, update, delete, the multi-threaded patient, create, read, update, delete, the single threaded bundle, create and delete, the multi-threaded bundle, create and delete jobs. So once they're all finished, you would then generate an output. And if the verbose parameter or argument was used, then you would have the verbose output, which includes much more detail around the execution of the bundle interactions. Or you would get the standard. If you didn't use the verbose, you would just get the standard output. So what I found when I was testing then, so on screen, I'm showing some of my summary results from a test system. So this was a FHIR server with an embedded H2 database running the Docker container. So this is not a production system. This is just a test system I was using. And I ran this on a M5.2x large, which is an 8 vCPU and 32 gig machine. I was running the prototype on an M5.x large, which is a 4 CPU and 16 gig of RAM machine. and it generated these results. So what I did spot was that individual results can vary greatly on different runs. And so it's important to then run many and average over those to try and minimize the impact of anomalous results. And with large quantities of results, you really need to summarize these to make them digestible, which is what I was doing in these summary results. And the way this works is that for each one of the resources that an interaction is happening with, that is performed 5 times. The average of that is obtained, and then an average over all of the interaction runs, so 1,000 create runs, is then performed, which then gives you the average response time and a representative average response time that you can compare against other results. Of course, these average results are only useful for comparison within a controlled environment. So when it comes to the benchmark machine, if you're running against 2 different servers, it's probably best to run from the same benchmark machine. It's also best to have network latency being the same between the benchmark machine and the FHIR servers under test. Another thing I included in the results was the percentage success. And the reason why I included this was to identify any bottlenecks, because if you're not getting 100% completion, but close to it, then you would notice that some of the interactions may not have completed, and that could have been because the server was being overloaded. Or if you got a 0% success rate, it was a sign that there was some form of incompatibility with that particular server. And what I noticed with this was that these tests could be very lengthy depending on the resources that they were running on. So initially I started off using a test laptop, and it was very slow to run on that because it didn't have an awful lot of resources. But when I moved onto something, a faster laptop, it was much better. And then when I run it on the servers, it was even faster again. So how can I improve this prototype? Well, I can improve it by adjusting the parallel runs. So I have the single threaded test and then the multi-threaded test. And the multi-threaded test works through doing 8 processes in parallel and running that as fast as the benchmark server and the FHIR server under test could handle. But what might be better would be to run a certain number of interactions per second, and then to obtain the response time from that. So for example, do 100 interactions per second, 500 interactions per second, 1,000 interactions per second, and then to measure that and see how long each of those occurred. And you could probably trend and figure out other bits and pieces and certain limitations within your system by doing that. I didn't include search. I realized search is a very common interaction within certain client workflows. So that's probably something that should be added. And with the other scaffolding that I have, I should add a custom job functionality. And that would also allow tailoring to meet the specific benchmark requirements, as I explained earlier, close to whatever it is that you're trying to test in production, rather than just the generic. And then to wrap up then, what are the benefits of the FHIR benchmarking tool? Well, it lowers the effort and the time to test RESTful FHIR servers. For academic researchers, they're going to be able to spend more time on their specific research goal rather than messing about with the performance benchmarking side of things. And in industry, it allows just rapidly testing without a large investment in time. And of course, you generate these outputs and you can use the summary outputs for a snapshot of performance, or the detailed for really delving into why or find out more about the performance characteristics of your system. Please reach out to me on the details on screen. I would love to hear from you. And thank you very much for attending my session. Okay, I'm just now going to take some questions. If there's any that's come in.
So the first question we have, Steve, is your tool open source?
Okay, so I haven't open sourced it yet. Something I'm considering doing. I very much believe in sharing what people have done. I guess as it was something that I've done for my master's, I was working to the time that I had set with that, and I would like to spend more time before I open it to the wild. But I think I will be happy to share it eventually whenever I've went over it again. So it's very likely to be the case.
Okay, the next question that's come in is, have you tested servers other than Happy?
Yes, I didn't. So for speed, I was using what I could deploy or what I could run in a Docker container. So I did test with FHIR and I did test with Happy. But what I would say is that whilst it's okay to do that, I think it only really becomes meaningful when you're testing it against a system that's like a production system, because the thing is, a lot of these FHIR servers will come with a database which is there to help you get up and running quickly and to use it for your development needs. So, you know, for example, the H2 database that was at Happy, and you can run, I think FHIR uses SQLite, if I recall correctly. You know, obviously, when you're testing against those, there are other bottlenecks other than just the implementation of the FHIR server itself. So I think it's because of I didn't share too many of those results because I don't think it's fair to do a comparison against those when the underpinning system's limited by the database more so than anything else.
Okay, before we go into the next main question, there's a couple of follow-up questions asked by the original requester there. Sure. And the first of those is, how many max threads did your multi-threaded test hit?
Yeah, okay, so I was, so I had 8 processes running and with running as quickly as possible, and the maximum that the on the results slide, it actually has the maximum that it could sustain. So let me see if I've got that here. So I'm just trying to look at this.
If need be, we can come back to that one, Steve.
Yeah, sure. Let's go into another question while I look that up.
Okay. The follow-up, your second follow-up question to that was, were the test client and the test server running on the same EC2 instance?
No. So the test server and the testing system, the prototype, were on 2 different machines. Yeah. So one of them was an 8-core machine, and the other one was a 4-core machine. 8-core with 32 gigs of RAM and 4 cores with 16 gigs of RAM. So I was running the prototype from the 4-core 16 gigs of RAM machine. Initially, when I started testing, I was using my laptop and it was very slow. When I mentioned it was slow during the presentation, I didn't go into numbers, but it was taking a very long time for me to actually execute the test results, or to execute tests in excess of 60 minutes to run on the laptop. It really does need quite a bit of grunt to run through them, especially with the bundles, which take much longer. When I was running the entire test from start to finish on the production systems then, or the sorry, not production systems, but the actual servers on the EC2 instances, it was completing in under 30 minutes, well under 30 minutes. I think maybe 15, 20 minutes some cases.
And then moving on to our next question, which is from Amina, who asks, what performance metrics are you really testing? And I assume that what he's asking is which specific metrics were involved in the tests that you ran.
Yeah. Okay. Well, essentially, what I was trying to find out was how a server would handle all of the usual interaction types. So, you know, I wanted to be able to identify if a server would be stronger or better at dealing with, you know, creates or reads or updates or deletes. So if you have a profile, again, trying to mimic as close as possible to what the real life system is. If you know a system is going to be predominantly used for just reads all the time, then, you know, I mean, read is obviously something that's going to be quite heavily used in most use cases, but you want to have really excellent performance with that. So what I was trying to do was essentially get a good spread, because as I mentioned as well, it's designed to be a generic benchmark just to give you an idea of how it should handle each, you know, each of the common interaction types that are out there. So, and the same, I was testing originally with single patient resources, but also with bundles, and the bundles have many different resources within them, which puts a much bigger impact on the server. So, you know, if that was your use case and you're putting in bundles which contain maybe, you know, 100, 200 resources, then that you'd want to be looking at to see how the create performance would be for that. So I was trying to capture as many possible potential, you know, a good broad spectrum of tests to see in each case. And the reason why I was doing the single threaded and the multi-threaded with many processes, which I peaked at 1,330 interactions a second. It was the highest I could get to, because the previous question had asked what I got to. And what I was trying to determine was, is the server more impacted in a specific type of FHIR interaction? So, you know, for example, when it's under load, how badly is the create interaction impacted? You know, how badly is the update interacted? How badly is the read impacted? So, because, you know, if you look at how different servers handle that, you'll find that some of them are better at some of those resources versus others, and that might be the server itself, the resources given that, or it could be the underpinning database, in which case it might be, you might choose a different database type. So the idea with this being that with a good broad spectrum, you could potentially make tweaks or changes to your system, rerun this, get better results, in which case, you know, you've made an improvement. That's the general idea.
Okay, the next question we've had is, did you vary payload sizes to see how that affects performance?
I didn't, and that's what I think would be exactly where I would take this next, because I was very constrained for time. Under my master's, I only had a certain amount of weeks to complete the work, and whilst I would love to have done that within the time scale I had, I just didn't have the time. And I think the beauty of doing something like that is that you could see how, again, talking about how a server is impacted under load, there might come a point where you put a certain incremental amount of load and you see an exponential impact on that, in which case, you know, you probably hit some sort of underpinning or limiting factor within the FHIR server itself, or the underpinning resources of that FHIR server. So I think it would be really interesting. I think the data you get from doing that would be great. So that's exactly where I would take this now.
And then we've also had a follow-up question to that one, and that is, you let the database's total size grow to see if that impacted performance.
That's not something I considered, but that would be a pretty that's definitely something that would impact you in a production system. So it's perhaps something that could be tested. I think, again, because of the nature of what I was testing being synthetic, it's hard to simulate that. But that, I mean, you could just feed it lots and lots and lots of data and grow it and see how it's impacted. I think that's a good idea, because definitely you it's definitely worth checking that, the impact that would have in your particular system. Again, if you've got specifics, then you'll know exactly what you want to target. So, you know what your FHIR server is going to be running on, what the underpinning database is like. You've made all those decisions already, then it's just a case of going ahead and testing that. I suppose in my case, I was just trying to do generic sort of a shotgun spread approach of trying to test as much as possible, and that's not something I had in scope.
Okay, that's all the questions in the chat so far.
And that's actually all the time we have for this session. So Steve, thank you very much for the presentation. The recording will be available later today for any of you to catch up. And if you have more questions, please enter them into the chat and Steve can check that later and enter any answers he has. Thank you all.
Thanks for attending. Thank you.